The focal length of converging lens is measured for violet, green and red colors. It is respectively FV, FG, FR. We will get A. FV less than FR, B. FG greater than FR, C. FV equal to FG and D. FG greater than FR. Here we are given three colors and we know that in the spectrum red is the one with the most wavelength and violet is the one with the least wavelength, and in the middle we'll get green. So in terms of wavelength, for R it is more, for V it is less, and for G it is in between. So we know the relation between wavelength and refractive index. They are inversely proportional. If it is not directly known, we know V is equal to C lambda, and we also know that velocity is inversely proportional to 1 by mu. Here velocity is directly proportional to lambda and velocity is inversely proportional to 1 by mu. So we can take this both together and we will get this itself. Otherwise we know directly that lambda is inversely proportional to mu. So with this relation we can write here for violet refractive index will be greater, and for red refractive index will be lesser, and green also it will be in between. Comparatively only we can get the value of green, whether compared to violet or compared to red. Now we have to write the lens maker's formula, which is 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. With this formula we can understand that 1 by f is directly proportional to mu. That means mu is inversely proportional to focal length. So if mu is greater, that is refractive index is greater for violet, it means focal length is lesser for violet, and for red it would be greater. So now we have our focal length relations. Now we just have to compare with the options given. So with the what we found, we know that focal length of violet is less than focal length of red, which is our option A. So we just don't have to check other options. We got the answer straight away.